Alright, so today's work is on applications of the unit circle for 5D.1. I've got 3 examples to work through. So hopefully you can see there. We have to find the possible exact values for cos when sine is equal to 2 on 3. There is one identity that we use a lot in trigonometry. It's got squares in it and a 1. Has anybody memorised that yet? Alright, I'll put it here. So it's cos squared theta plus sine squared theta is equal to 1. Do you remember us talking about the unit circle and that it's a hypotenuse of 1? So that formula is actually from the Pythagoras' theorem, where a squared plus b squared equals the hypotenuse squared, and these represent the 2 sides of a right angled triangle, where the cos represents the horizontal component, so we're squaring that side, and the sine is the vertical component in a right angled triangle, and so technically that's 1 squared, but 1 squared is 1. So learn that one off by heart. Now we substitute in what we know. Okay, alright, sine theta is 2/3. Alright, I'm going to put that in there. So cos squared theta is still the same. Now, the square goes on the end there, if you like, so we have to square 2/3 in a minute, and that's equal to 1. What should we rearrange for when we're trying to get on its own? The cos. So all the number stuff we take to the right-hand side, that is 4 on 9. You can use your calculator for the number parts. So we're left with 1 subtract that, 5 on 9. Now it's cos squared theta is that. We want cos theta on its own. How could I undo that? You can square root. Just a tip there. You might be thinking, yes, miss, but the square is inside the thing. Usually the square has to be external for me to undo a square. For the record, that is the same as that. So the square is inside there or on the outside there, equivalent. So therefore you're allowed to now square root both sides, which will leave you with cos of theta here, squaring those, 5 on 3. But when we undo a square root, we have to take into account the positive and the negative ones. And because cos can have 2 values there, and that makes sense in the unit circle, it could be on either side. And it does say to illustrate our answers. So what that means is to draw a unit circle. You'll have so much practice at this over this topic. So we're drawing it there. Let's start with the sine is 2/3. Now sine relates to which part? The x or the y? The y. So if y is 2/3, is it positive or negative 2/3? It's positive. So we've got, remember it's a unit circle, so we've got 1, 1, negative 1 and negative 1. We're going up 2/3 of the way to 1 on the y-axis. So about there. So there are 2 points where sine is 2/3. It's here and here. So that's 2/3 there and that's 2/3. Now let's think about the cos. At those points, we're saying that it's root 5 on 3. So that would be down here and down here. So it's essentially those 2 spots on the circle. And here we have root 5 on 3, and over here would be the negative root 5 on 3. So there we've illustrated our answers. So our next example here. If sine of theta is negative 3/4, you might like to try and visualise where on the unit circle the y component is negative 3/4, where that might be. And we're in this section. So our angle is in there. We have to find cos and tan. I'm going to go through all of these bits and what they mean. So we have to find cos. What do we know? We know sine. When in doubt, try and use that formula for trig with the cos squared theta plus sine squared theta is equal to 1. You'll get that off by heart. Let's substitute in what we know. We know that sine of theta is -3/4. So we have -3/4 there, and you square it, equal to 1. Rearrange finding cos here. We would get 7 divided by 16, so I've just calculated that and subtracted it off the other side. I've got cos squared at the moment. I just want cos, so I need to square root both sides. 16 is a square number, so that's going to come out to 4 and 7, but we have to take into account the positive and the negative versions of cos. Now, can we decide though? I wonder if it is the positive or the negative. Let's think about where sine of -3/4 is. So you need your unit circle. So draw your axes, draw a circle, and think about where this section is. What's the one thing that you learned off by heart? Pi is equal to 180. So 180 degrees comes around here, there is pi. So we want our angle to be between pi and 3 pi on 2. That's 3 halves. 3 halves of pi, that's 1 half of pi, 2 halves of pi, 3 halves of pi. So our angle actually has to be somewhere in here for this question. So our sine is -3/4. So that means we come down on the y-axis down to -3/4. And the two options you could have here are over to the right here or over to the left. Well, clearly this one is not the one we want because it's not in our quadrant. So we want this here. So that is -3/4. So which cos one do we want? Have a think. We want the cos that matches that point. Is that for the x on the negative or the positive side? It's negative, so therefore we want the negative cos one. So we want cos theta is equal to -√7 on 4. So we've done part of our question here. We've found the cos of theta is -7 on 4. But we have to find the tan. Tan of theta. You learned something about what tan is equal to? It's a fraction.
Sin.
That's it, yep. Sin or sine over cos. So the way that you work that one out is you substitute in the values that you have. Your sine is -3/4 and your cos is -7 on 4. And just quick refresher on fractions. If you've got a fraction on a fraction, what do you do to work that out?
A, D, O.
Yeah, so you know the letters, but what's the concept?
Just times the bottom on the top.
You flip the second one, so 4 was on the bottom there, now 4 is on the top, and -√7, and you turn it into a multiply. And you can see what's going to cancel there, and we are left with 3 on √7 for tan. Have we answered the question? Yes. We've given them as exact values, which means with the square roots, not doing decimals. All right, and our last one here, if you know tan is -2, and we're in this section, we need to find sine and cos. How could tan help us find sine and cos? The tan of theta is equal to sine of theta divided by cos of theta. We know that's equal to -2. You might be thinking, okay, well, I've got 2 unknowns here. That's going to be a bit tricky. Let's just rearrange that. And we've got sine of theta is -2 lots of cos theta. So that's probably where we're going to halt on that one for a second. What's another trig identity I've done in the previous 2 examples? One with a square, that sine theta plus cos squared theta is equal to 1. I reckon I've been doing it the other way around. In the other ones, I did cos first and then sine first. I did. Actually, doesn't matter. Which way around you add them up, they'll still be equal to 1. So that's a good tip to know. Okay, well, let's substitute that in where we see sine and see what happens. So I've got a sine here. I'm going to put -2 cos theta in here. Using brackets, -2 cos theta all squared add on the cos squared theta is equal to 1. Can I simplify this a little more? The square here, when you calculate that, you must square the number to get 4, and you must square cos. And where we write that square is inside, between the cos and the theta. Now this is like collecting like terms, strangely enough. I've got 4 lots of cos squared theta, and I want to add on 1 lot of cos squared theta, so I'll end up with 5 lots of cos squared theta is 1. Now I'm trying to get cos theta on its own, so I'm going to divide through by 5, and I'm going to square root both sides. I'm going to do that in one go. So if I was to divide through by 5 and then square root that fraction and take into account the positive and the negative version.
Does it matter which way you do it? Or?
Does it matter which order?
Yeah.
It does. Think about how you would build up functions. It's 5 lots of cos squared theta, so that has to be undone first and then the square. Good question. Now, I've got 2 options for cos here. Let's see where in the unit circle that's going to sit. Draw our unit circle. So the question has told us that the area that it wants you to look at is between 3 pi on 2 and 2 pi. 2 pi is 360 degrees, so that's all the way around to there. And 3 pi on 2 is here. So it actually just wants us to look in this section. Let's think about which way around I want to do this. Because in this section, did you learn cast? Or another version about turtles?
Yeah.
Which one did you learn? Cast or oh, silly turtles crawl. What do the letters mean? They're positive. So the letter that's in that quadrant, those ones will be positive. Right, so A for all of them are positive in that quadrant. Down this quadrant with C, cos will be positive. Let's look back over here. What does this tell us about this then? They're positive and negative. We only want the positive version of this one. So we want positive 1 on root 5. So that's good. So I found cos is equal to 1 on root 5. Now the sign. Well, first of all, is it going to be positive or negative in this quadrant for sign? Negative. So I know that I'm going in that direction. Perhaps I'll just put a negative sign there. How could I find sign though? Is there any other thing we've done over here that might help? I feel like a newsreader here, just watching myself. Anyway, sub it in there. So we've got sine of theta is equal to negative 2 lots of cos theta. Well, I know what cos theta is. So I'm going to substitute in 1 on root 5 to work out that sine is negative 2 root 5. And that matches with what I thought, that sine was going to be negative. Have we finished the question? Yes, make sure you give exact answers, which is keeping in the surd form.